How do you ensure the AI model maintains accuracy when you have a diverse data set? Now, you really only have control over two things, right? The data and the model itself and how you train it. The problem specific that we're seeing here is diverse data sets and maintaining accuracy. So say, for example, the model can be generalized and can learn all the data, although you might be underfitting in the model, which helps the model learn generally the idea, though it will miss the mark when you provide it an example that it's already seen or it's really close to have been seen, and it can get it wrong because of overgeneralization. This can occur because of diverse data sets. There's strategies that we need to take in order to solve this, because it is a problem. If you give the AI something that it knows it's seen before, but it has been overgeneralized, then its accuracy is going to be lower, and essentially this is called underfitting. So we can solve the underfitting problem by a lot of different ways. One is you can just create separate dedicated models and then figure out which model makes the most sense, so the diverse data set becomes more precise based on the domain knowledge. That's a more annoying approach, which you can totally do and it will absolutely work. There are other tricks that we should investigate first, such as how you architect the model and how you train the model, but also the kinds of data that you provide in the model. Say we do have a nice, clean, diverse data set. So in that case, you might have covered all the bases. You have like a full coverage of all the data. So there doesn't seem to be a whole lot we can do to improve on that, to improve the data itself. Though what we can do next is maybe look at how we are training the model. From an overfitting perspective, when we're training the model, we have things like learning rate, batch size, how long you train the model for, and to some extent the weight initialization. So what we really care about here in this case is going to be the batch size and the number of epochs. When you are training a model, you want it to be able to remember as much as possible, but also have enough general knowledge so it can give you a good answer, a high accuracy answer for data it's never seen before. So with the batch size, the bigger you make this, the more general the model will be in its knowledge. So if you have a really big batch size, you're going to be able to train the model to approximate really well across these different data sets. Now you could strategize your batches so that way certain segments of your data match certain domain knowledge. That could be an approach. So you still have the same model. Instead of batching randomly across all pieces of data, you can batch with segments of domain knowledge. That could be an approach. Another idea is to just have smaller batch sizes. This does take longer in training, specifically if you have GPUs, because every time you submit a batch, that is a blob of data that gets submitted to the GPU that can get processed and returned back to the main memory. And so by reducing batch size, you might increase the time it takes to train the model, though you will increase its accuracy and its memory. Another thing is I was thinking here is the number of layers and neurons. If you want to have more knowledge and higher accuracy for things that it sees in the past, you could increase the number of layers and increase the number of neurons, which is the number of parameters, right? The coefficients in the model, the numbers in the matrix. You can just increase those numbers. That can help as well. So we're talking about underfitting on a model where the AI model overgeneralizes on its knowledge. Essentially, you give it all the information. You have a really good data set, and that data set includes the whole spectrum of all possibilities for the most part. And the problem is it's going to average everything out, and it's not going to be able to remember any one individual thing. So there are approaches and ways to tune and tweak that. So a lot of the idea is say for example, most of the time you don't have enough data. And so you do want to have a higher generalization. In this case, though, with a diverse data set where you have all the information you need, you want to improve its memory. You want the model to remember things that it's seen. So regularization is a way to help the model generalize better. You want it to not overfit, so you introduce regularization. The problem is, though, if you over-index on any of the regularization, you're going to get into the scenario where we're underfitting. You might want to reduce your reliance on these items. You can keep them in there, just reduce their effectiveness. Overall, just kind of stop make the numbers lower, less impactful. So that's something you can do. This will help the model remember more specific things. You can also, along the same lines, to sort of reduce the gradient clipping limits. So if the model's, being able to approach an overfitting, because you do want it to remember specific things, you can use gradient clipping. Actually, now that I'm thinking about it, you could have two models, one where it knows it remembers specific things, and then it can identify, and you can maybe overfit a little bit, and then you can have another model that's more general, and then it can help sort of offset that in case it's seeing data that it's never, it never ran into before. Though it's very difficult for you to determine which of the two models would be accurate in that case. Either way, this is a hard problem. This is why AI and machine learning is so advanced and complex, because there's so many algorithms that go into it that you need to sort of balance, or else the model, when it learns, it's just going to forget things, or it's going to overgeneralize, or it's going to take way too long to train, right? Because you can cram it with more memory, and the more memory you give it, the better it can help generalize on very specific segments. You're going to just run into problems though. In machine learning, one of my favorite things is data augmentation, where we synthesize data and take our inspiration from our original data set, and then we add to it with synthetic data. And you want to do this because you want to increase the model's accuracy overall in general purpose cases and in specific cases. So what you can do is, if you see that your model seems to be tending one way or another, either it's overfitting or underfitting, you can synthesize data to sort of even out the model, but also sort of index on certain areas where you want the model to maintain its memory and accuracy. So you can generate even more data in that case. So you can just 100% rely on synthetic data without having to change any of the parameters in your model. You can just create more data. I really like this approach. So things like, imagine like photographs, right? We can have a lot of photographs of, say, dogs and cats, though in many scenarios, you're not perfectly centered on the dog and cat. The dog and the cat might be in different parts, or it might be rotated. So something you can do that's very common is to take the data that you have with the cats and dogs in the photos, and then rotate them, scale them up, flip them, move them around, and this becomes additional training data that's all completely based off of your original data set, and it improves the accuracy of your model overall. I really like this approach, data augmentation. It does take, I would say, a lot more work than tuning a hyperparameter, say like a batch size or number of layers or number of parameters in the model. That's a lot easier because it's just changing a few numbers. With data augmentation, you really have to go back, write some code that will generate the data for you, that will improve the accuracy of your model. That's a lot of what OpenAI has done with their ChatGPT and the newest model, ChatGPT 4o. That model was mostly completely improved by data augmentation in that approach. That made the model faster because they didn't need to over-index in larger models with overfitting, and then they were able to reduce the size of the model in that case, and then they were only able to really focus on what everyone's using the models for the most. So they were able to under-index on some of the data that didn't matter as much, focus more on all the use cases that everyone's using the model for. And that is a lot of the time of data. It's all about the data. When we're training an AI model, there's a concept called early stopping. This idea is, well, essentially here's the problem. You can train an AI on an infinite loop forever, and it will get to a point of diminishing returns every single epoch or cycle, where it has completely traversed all the data points that you've provided it, and then it needs to go over it again and again and again. And every time it goes through your entire data set, that counts as one epoch. What you could do is stop early. But when do you stop? The model could run forever and train infinitely. You have to find the diminishing returns. You could simply find a minimum delta of change between each cycle of accuracy based on your test data. So that is one way that you can use to help improve the speed of training, because when do you stop? You don't know when to stop. But in this case, with early stopping, you can do things that prevent overfitting if you're having an overfitting problem. But guess what? If you're having an underfitting problem, which is mostly what we're talking about, you don't really want to stop early. You might want it to continue to go forward so it can continue to converge and understand more about the data that you've given it, even though every single step it's going to learn less and less, it's still going to be able to reduce its generalization and remember a little bit more. So keep it running longer if you want to reduce underfitting and then sort of index more closer towards an overfitting scenario. That's what you need to do with the diverse data sets. All right, we're talking about strategies to reduce underfitting with machine learning models, and a lot of it comes down to data, right? And how you strategize your data as you're presenting it to the AI model to learn. You want to be able to be very specific about what you teach it. Now, what you can do is balance your data sets and segment the data into specific buckets, which you can use to change over time. I really like this idea because what you can do is you can train the model on the diverse data set, and then you can segment the data that you want it to remember for very specific cases, and then retrain the model using the previously trained generalized model, and then train it again on very specific data sets. So you can take, this will help a lot with imbalancing and also any places where you might be undersampling more important aspects of places that you want to maintain accuracy, where you have definitive ground truths that you don't want the model to undergeneralize on or overgeneralize on. You want to make sure that the model is able to provide the highest possible accuracy for things that you know are for sure. But also at the same time, you want it to know those things and draw conclusions to things that it's never seen before, which is a really important aspect to what AI is in general. So I really like taking data set strategies, and this is gonna be by far the most important but also the most annoying to deal with because it's a lot of work. Data set classifying, labeling if you're doing supervised training, synthetic data generation, that's a whole thing. What is this smote? Hold on. I put a note here about smote. We need to see what smote is. Synthetic minority oversampling technique. Okay, so say you do have a diverse data set, though you have an important part of your data set where you only have a few points of information, right? So you have an underrepresentation of data that you need to augment, right? And so in order to make an improvement so the model doesn't forget those very important data points, you can either duplicate it, or you need to go in and improve that, or retrain the model, index the model a little bit more heavily on some of those minority aspects. You could also do that in the opposite direction. I mean, depending on what your need is. Really, it comes down to what you're showing to the AI model as it's training, right? That data. You need to give it the right information so that way it can draw the right conclusions when you're running the AI in inference mode, when you're sort of having it predict, right? When you're having it create the answers. This is the strategy. Overall, biggest thing and the most annoying thing, of course, is going to make sure that your data is exactly what it needs to be so that way the model can perform the best overall. There are so many cool things you can do with an AI model when you're training it to learn something so that way it can better come back to the future and have a really good accuracy as it is being run in production. So the idea is, as you're training the model, it really comes down to the data and that you show it. One of the approaches that some industry leading companies, they use something called domain expertise. The idea here is you create a base foundation model that has a general knowledge of everything, right? And it's basically underfit, right? It underfits because it generalizes and it performs well generally, right? Like maybe the 80-90% range. However, if you want a model that performs really well in a specific domain area, you can then go back and take that foundation model and then train it again with specific data sets. This is all about data manipulation. Do you show the model when you're teaching it, right? What information are you going to give it? So you can generalize the model, foundation model, and then go back, copy the model, and then create a new model with domain expertise where you feed it specific. This is often called like fine-tuning or transfer learning, though in many cases you can simply just retrain the model without freezing any of the layers or adding new layers. You can just take its foundation, pipe in more data that has a very specific domain of knowledge. And what this will do is take your 80-90% accuracy all the way up to 99% accuracy or higher. And you're like, how can you go higher? Well, I mean, at a certain point, 99%, even though that sounds really good, it means it's wrong one time out of every 100, which is a problem. You would want to increase the accuracy as best as you can, of course, beyond that. Although when you go back and step back and then you run a scenario where we index on the performance of a human in those scenarios, how often does the human get it right? Does the human get it right 99 times out of 100 and gets it wrong once? Or is the human actually worse? In which case, the AI can outperform humans if it's at 99% accuracy, even if it gets it wrong one time out of 100.